Welcome back, my friends. It's Perry once more, here to talk to you about a really important topic, and that's servers. And servers are everywhere. You never really see servers. They live in these places called data centers. And basically, a server is, well, it's a computer on steroids. So we went through quite recently what a computer is. A computer basically can be a server, and a server can be a computer. But the thing to keep in mind is servers do a lot of work, so they tend to be much, much bigger. Bigger in terms of things like your memory, like your random access memory. It uses a lot of that. Your motherboard might be specialized in a server. It might have more than one hard drive. In fact, it probably does. It probably has several hard drives where that data is protected. Different operating system. The operating system's super important. It might have multiple network connections, so multiple different networks can hit that server securely. Probably definitely has more than one CPU. The video card, not as important on a server because you're not going to play video games on a server, but still, you need one. The screens tend to be optional, and I'll talk more about that in a second. Lots of applications, but those applications tend to be more server-based applications, and we'll walk through those in a second. So everything a computer has, that's a server. I've set up servers on really small, like Mac Minis, or on huge, big systems with like 8 different processors and 128 gigs of RAM. At the end of the day, they all serve the same purpose. When you're thinking about servers, though, it really kind of comes down to how much can the server do? How many people can it service? How many applications can it service at the same time? And hardware, specifically CPU, memory, and hard drive space, play a huge portion in terms of how a server is used and allocated within an organization. But basically, when you think server, think a computer, blow it up on steroids. But the main difference of a computer is that it has a different operating system. And that operating system allows that computer to then start serving up different pieces of functionality. So the term server applies to both the physical and virtual. Now this is a little tricky, but let me try to walk you through it real quick. Virtualization is the art of creating multiple server instances on one physical system. So back in the old days, you didn't have virtualization. I say old days, like 8 years ago. You had lots and lots of physical computers, and those computers served a specific purpose, or you might have multiple servers serving one purpose. So for example, email. There would be a dedicated email server, and all that server ever did was serve up email. And there might be a dedicated web server, and literally think of a big computer in a rack at a data center. That's what it was. All of a sudden, people began to realize that, hey, wait a minute, all these servers are being underutilized. They're not using all their CPU. They're not using all this memory. What if we virtualized it? So what they do is they create an instance, and now they can run multiple server instances on one physical system. So this is important to keep in mind because when you hear the word server, it means both software and hardware. There's the physical server sitting in a data center, and then there's the actual functionality the server is providing. And that server also might be virtualized, providing all those different services to your company or to people as an offering. Things like Facebook and whatnot. All these folks have huge data centers with servers. Some are physical, some are virtualized. We'll cover some more of that here in a little bit. So what makes a server a server? Why is a server just not a computer? Well, a server has a specific operating system that contains services. So let me say that one more time. A server has a specific operating system that contains services. The whole point of that big computer, the beefy computer that they call a server, is to provide different services to your organization. Or if you have a company and you're selling products, you want to sell them online, for example, or what they call software as a service. Those servers exist to provide functionality. Again, email servers, web servers, that's what's there. So the server operating system is what makes that possible. So some of the services provided by servers. Now I'm going to hit this one more time. A server can be both physical, but primarily the server itself is the operating system that provides services. So if there is a system, a computer that's providing systems with a server operating system on it, you would call that a server. So there's lots and lots and lots of services that can be provided by a server. First one, and I think probably one of the most important, is the directory service. So when you log on in the morning on your computer and you're on the network at work, first thing it does is it goes out and it hits a directory service and says, oh, hey, Perry, how are you? I see that you have access to these 25 things. You have access to your email inbox. You have access to the corporate intranet. You have access to these file servers, etc. And it knows what you can do and not do. And then hypothetically, if you went out and tried to get something that you to access, like say another internal research site or a file directory in HR, it'd say, hey, wait a minute, pal, you don't have access to that. And it would basically prohibit you from getting access to things that you are not authorized to do. So a directory service is the software system that stores, organizes, and provides access to information in a computer operating system directory. So really critical, probably the biggest directory service in the world, the one that's the most popular, used the most, is from Microsoft. It's part of Microsoft Windows Server, and it's called Active Directory. And Active Directory is probably used by 98% of the companies in the world. So when you log in more times than not, especially if you have a Windows operating system on your computer, Windows 8, Windows 7, soon to be Windows 10, if you log in at work, you're hitting Microsoft Active Directory, and that's what's determining what you have access to, what you have permissions to. Next on the list, we got the dynamic name service. Super important. So DNS, or dynamic name service, basically translates addresses. So think about your house. I live at 2222 West John Street. Okay, that's good to know. So every computer on the internet, whether it be the computer systems at Google or the computer systems at Yahoo or CNN, they all have an address, so the world can find them. So what dynamic name services does is it's pretty hard to remember an IP address. The IP address is that address to that specific site. And for example, I have one here, 192.105.232.4. That's a pretty typical internal IP address. An external IP address might be 206.143.20.12. Those are the addresses. So if you type that into your browser, you could go to CNN. If you knew what the IP address for Google was and you put that in your browser, you could go there. No problem. You can just bypass DNS. But no one's going to really remember these numbers. Our whole world around Google is all about searching for names. So what dynamic name service says, like, oh, hey, 192.105.232.4, I know that you're actually the company intranet site. So when someone types in the company intranet site, CorpCom, something along those lines, that DNS server goes, hey, CorpCom, I see you're actually 192.105.232.4. Here you go. I'm going to route you over. So it's translating the friendly name to the actual IP address that's required to navigate to that system, that environment. So again, it's translating that address. So everything on the internet has a number associated to it, but you can't be expected to remember all those numbers. So the dynamic name service says, no problem, we're going to translate them. And I've got another program I'll have up on the site soon, which is a really comprehensive overview of DNS. And DNS really does make the world go round. And there's a whole lot to it. There's actually big managed DNS servers out there that keep the whole internet afloat. And if they were to disappear, our whole lives would fall apart. And I've got a separate session coming up on that. But just for right now, DNS, dynamic name service, basically translates the addresses into a friendly name so you can easily find it on your network, on the internet, etc. So again, this is one service that a server can provide. File servers. You got all kinds of files, right? You got your docs, you've got your pictures, you've got maybe media files, and you need a place to store them. A file server basically is a big repository. You can just drop them in. You can associate permissions based on the directory services. So you can say, okay, only this group or these people have access to that file server. And it really is just a repository and a big library to keep all your files straight. Now, truth be told, file servers are starting to kind of fade out a little bit, and intranet products like SharePoint and other content management systems are taking over. But a lot of companies still have file servers, and every server product out there has a file server component to it. So it is important to know. Index search service. All right, this is one of my favorites. All this stuff out there, everything across your company's environment, your client's environment, your personal environment, the index server goes out and searches for it and tries to make some sense of it. So, let's say that you've got a corporate intranet and there's all this content on it, and you've got a couple file servers, and maybe you even have another company site that's at another location or outside the firewall. The index search service can actually go out and inventory all that content so that when you search for it, it will bring it back. And now the new index search services have gotten so much better, like the ones from Microsoft, the SharePoint product, you can do what's called security trimming. So let's say you have content that you're administering. Only those folks that are given permission via the directory service will actually see that in the search service. But really critical, we live in an age, there is so much data being created every single day, you got to be able to find it. So probably the biggest example of an index search service, Google. They are the kings of index search service, and that's basically what they're doing. They're going out and indexing all the different sites that are on the internet and finding them and being able to return information when you look for it. So to have an appropriate index search service available, super, super critical. Now, just a little caveat, this is a really process intensive sort of feature. So often index search services might be on their own standalone server, or they might have whole racks of servers dedicating to going out and doing indexing and searching. Just so I'd point that out. So you generally wouldn't see an index search server in conjunction with another service on a server, just because it is really so processor intensive. But super critical, helps you find what you're looking for. Next, we got proxy server. Now, proxy server, super important. It's both a kind of traffic cop as well as a security component. So the proxy server, it's generally a service that's available on the server, and you can have a standalone proxy server. And it acts as an intermediary, between the endpoint device and another server from which that device is requesting service. All right, so what's an endpoint device? Let's say that your company has 2 locations, and you're in Cleveland and the other office is in Seattle, and you want to go and hit and find a resource in your other office. So from your endpoint, it gets routed through the proxy server, talks to the firewall probably, and says, yeah, go ahead and route this traffic over. I think that's fine. So the proxy server is really critical for the whole security component to make sure that only people who are in the right location doing the right thing can get access to content in other outside locations, or that folks coming from the outside only get access to things that they have permissions to. And this also ties into things like directory services. But I know that's a little complicated, but just think of it as a traffic cop. You can go here, you can't go here. Web server. Of course, the web, that's everywhere. Everything we're doing, you're watching this probably over the web. Web servers, super critical. Very common to have, just dedicated web servers, especially depending on how much content you're serving up. The web service is the one that serves up the web pages. So it provides a service, it routes the traffic through those web pages, and the web service is super critical in terms of serving up that content. Database service. So we mentioned databases a little bit, really critical. A database is a collection of information that is organized so that it can be easily accessed, managed, updated, and databases are everywhere. Your data, if you have any kind of data, your medical records, your school records, your credit card records, they're out there in some database. So there are specific servers that are dedicated to being just database servers. So I think hopefully you're getting this now. So if a server serves a purpose, like the database server, you would refer to it as the database server. So again, databases are everywhere, and you have to have servers to run them on. Email service, sort of self-explanatory. It's a dedicated service to route your email so that when you go in via a web browser or via Outlook, you're hitting an email server. And that email server ties into the directory services and says, oh, hey, Jane Doe, I see here you're trying to get your email. Yes, you have permissions. Come on in. And then they can suck the email off the server. Email servers actually do a lot more than that. They do things like calendaring. They do a lot of scheduling components. They're a repository for content. So email servers have really evolved over the years. But just to keep it simple for right now, it's a dedicated service that runs on a server to provide email. Management server. Okay, so it's a little more complex. You got all this stuff going on. You've got permissions, patches, maintenance, and you've got big networks. The management server basically keeps track of everything and makes sure that everything's working as it should be. So it's really kind of the mechanic. It's like, is this working properly? Is this performing properly? Is this stable? And management servers are generally accessed by system and network administrators to ensure the health and well-being of that server. So within the Microsoft space, you have what's called System Management Server. And its whole purpose in life is to run and make sure that all the other servers and computers in the company are totally running as they should be. And if they're not, then it provides reports via dashboard that folks access that lets the system or network engineer know what's going wrong so they can be proactive about it. So management server really critical to a healthy network server environment. Firewall service. Firewall, again, we talked a little bit about proxy server, and firewalls work fairly closely together, but the firewall really is where the buck stops. It says this traffic from these IP addresses can come through, these cannot. It is the one that determines what gets access to what, down even to an application level. So let's say that you want to go out and download a piece of software from a company. If that firewall rule excludes that, you can't do that. You can't download that piece of software. The firewall will stop you. You can put in what's called website access lists, where you can block specific sites. So let's say hypothetically that you want to make sure that your company has no porn on the network, which is probably not a bad idea. You can put in an access list that says, block all these sites. I don't want to see any of this inappropriate content coming in. And they have programs for that where they basically accumulate those lists all the time. So firewalls are what keep you safe. Now the trick with firewalls is making sure that the network is secure, but also letting people do their job. So with the firewall, it's kind of, you really need good security and firewall administrators that are flexible enough to let people do their job, but are secure enough and know best practices to keep bad folks coming in, getting access to content they shouldn't have. So a really critical component to ensure that the network is safe. All right, print service. Lots of printers. Printers run off software. Let's say you want to go print. You browse to that printer, on your network, and then you click on it. All of a sudden, magically, that software for that printer downloads onto your computer. Awesome. So basically, it administers printers, and generally a print server will administer lots and lots of printers. So a print server, like at a big company, might have 1,000 different printers that it's administering. It's maintaining all the print drivers, that software that you download onto your system that allows you to print. It manages the print queues, who gets to go print when. Let's say hypothetically 20 people try to print to the same printer at the same time. It maintains a queue and says, okay, your turn, your turn, your turn. Generally first come, first serve. So the print server is specifically designed to administer printers and make sure that you can get access to a printer whenever you want and print what you need to print. Okay, we talked about virtualization. Really becoming the trend. It's pretty uncommon at this point to see a server as just a standalone system only running one instance. What generally will happen is you'll get multiple servers that will be virtualized. So let's say you have 10 different physical servers. You might have 40 different virtualized server instances running on those 10 servers. What this does is allows for greater administration and productivity and efficiency of those server resources. Because the thing you got to think about servers, they're expensive, not just physically to buy them, but they're really expensive from power consumption, from administration. You got to put them somewhere. Also, you got to cool them. A big chunk of money goes to things like air conditioning to keep those servers cool, because servers will overheat like that because they're doing all this work. What virtualization lets you do is let you use multiple instances across a smaller group of physical servers and basically squeeze out all that good processing goodness out of that server without having to spend a fortune on things like air conditioning and power. So I know that's kind of a confusing concept, and we're probably not going to get too deep on virtualization, but when you think about it, if someone says, oh, it's a virtualized server, what I want you to think about is 4 different instances where there's 4 different identities set up as individual servers in a virtual capacity on that physical box. So literally you could go, and each one has their own IP address and their own name and their own identity, and they are literally their own instance, and they're specifically doing a job. So for example, you could have an instance that's doing email, an instance that's a database server, an instance that's a firewall server, an instance that's a print server. You can serve up all this different functionality to serve the needs of the company and distribute those again across those different instances, and thereby really take advantage of the physical hardware power, air conditioning costs that you have without having to expand that out more, and just take advantage of the hardware that you have. So it's really powerful stuff. If you're interested, I'll do a more comprehensive virtualization overview in the coming weeks. But just remember, a virtualized server is one where there's multiple instances running on one physical server. All right. So in terms of server operating systems, there's not a lot of them out there. I would say definitely Microsoft dominates the corporate market. So at your office work, I guarantee you that 80% of what is running your company is provided by Microsoft. It's Microsoft Windows Server running on physical servers, probably from Dell or HP. That's probably the most common thing if your company hasn't actively started moving into the cloud. So Microsoft really dominates the server space. And all these services that we went through here, the directory service, index server, proxy server, DNS, file server, database, email, all of these are available on Microsoft Server. So it provides all those services. It's deeply, deeply, deeply powerful. And it's the most common, dominant player in the marketplace. It doesn't seem like it's really slowing down. I think the cloud is making things kind of interesting for Microsoft, but that's a whole different conversation. But really, it owns the space. It's a great product. I've been working with it for years. It just keeps getting better and better and more stable all the time. So if you're starting to think like, oh, I want to maybe be a systems administrator, I want to work with servers, you're really going to want to get up to speed on the Microsoft products. Now, in regards to websites, things like you're going out there and you're hitting like Google, or you're hitting Facebook or others where there's lots and lots of web traffic. Apache, which is a Unix platform, is the most common website platform. So I would say probably there's at least a 65% chance that you're hitting an Apache site when you go to most of the websites out there. So if you spin up like a WordPress site or you go to an e-commerce site, most of that is probably running with an Apache backend. Apache is running 352 million websites around the world. That's insane. Just the thought that there are 352 million websites blows my mind. But it's still a really dominant player. Now, kind of competing with Apache in the Linux space, I think we talked a little bit about Linux with computers. Linux is an open source system that was developed about 10 years ago, and other companies have come along and used that Linux platform to develop products to sort of compete with Apache or Microsoft. One of the biggest ones is Ubuntu. And that is a Linux product that basically acts, it's predominantly for web servers. So you might see Linux in specific type of scenarios, but really Ubuntu is sort of competing more directly with Apache, like for the web server, like serving up websites. That's really kind of its core offering. But as you're getting started, you're like, oh, I would really like to get in and learn more about servers. Just my personal recommendation, you're probably better off, especially if you're looking to get a job as soon as possible. Getting into the Microsoft space is the best thing you can do. Microsoft also has a really clear-cut education program where you can get certified within a short period of time. So they have a track called the MCSE, Microsoft Certified Solutions Expert. And they have one for all their server products. So every single service you saw, the email, the web, they have specific courses and certifications for each one of those services so you can become an expert in them. Just plant that seed there if you're actually thinking about, I might want to get into this game. That's what you want to be taking a look at. All right, folks, thank you so much. I really appreciate it. And stick around for the next course.